Hi everybody, Zach Howell here, going to talk to you about biomechanics in sport, specifically the coefficient of restitution. Now, when you think about how bouncy an object is, you get those super bouncy balls that you just slam into the ground and they go flying into the air, lots and lots of feet. It's because they have a high coefficient of restitution. So it can be, thought of as the bounciness of an object. So generally, an easy way to describe this is simply from the square root of the drop height and the bounce height. So we're gonna drop it. I'm 6'2", so if I drop it from shoulder height, so we'll say 5'7", right? 5'6" from my shoulder. We're dropping it from that high. How high does it bounce back? That's going to be our coefficient of restitution. So we have three different objects here to demonstrate this. First one is this 20-pound medicine ball. If I just drop it straight out from in front of me, it doesn't bounce very high because it doesn't have a very bouncy material, right? But if I get a basketball that's well inflated, shoulder height, drop it, how high does it come up? That's going to be our coefficient of restitution. Same thing with this lacrosse ball. Hold it shoulder height, remove, and see how high it bounces. What we can do is we can compare these two, this basketball and this lacrosse ball. Which one has the higher coefficient of restitution? I would say that the lacrosse ball bounced a little bit higher. Another way to describe coefficient of restitution is the velocity, the absolute velocities with which two objects separate after they collide from an elastic collision, right? So how fast do they separate when they collide versus how fast are they going prior to that collision? And that will give us our coefficient of restitution there. And we can also see, okay, which one of them is bouncier? Well, there's also many factors that go into that, such as linear momentum, and the mass of the object. The lacrosse ball and the basketball, they have different masses. They also have different densities, which can play a part in, okay, how bouncy will these be when they collide?